this is Pure 2 Chapter 9, 9.10, the last part about differentiation. And after today's lesson, we can call differentiation a closed chapter. No, not quite yet, because in integration we'll need a lot of differentiation as well. But it'll be good to move on to something else fresher after differentiation, after so many lessons of differentiation. Right, so in this lesson, we are learning how to construct differential equation. So an equation that involves a rate of change is called a differential equation. Like previously, we've learned about how to, construct one similar one. These are called differential equation. Now, what we learned today is slightly different. We're going to make it out of words. So you can see the examples and practice question today will be a lot of words, and you're required to make a differential equation out of it. You need to know how to construct, how to create a differential equation, which is the harder part, today's lesson. And then you're going to learn how to solve it through integration later on in chapter 11. Now, there is no one rule that fits all strategy to construct differential equation. So the structure of this lesson is going to be, I'm going to do one or two examples with you to show you how to, to show you the know-how. And then a lot of practice question, you will have to try it and then pause the video, play it, and then I'll go through with you in case you get stuck and hopefully get an idea how to construct it. Okay, right. So example, in the decay of radioactive particles, the rate, remember one rate means one derivative. Okay, one differentiation fraction, whatever it's called, differentiation fraction, which particles decay per minute t is proportional. So this rate, by the way, tells you d something by d something. I don't know. Okay, let's not use a cross in here. Maybe let's use d something by d something. Okay, so the what rate tells you d something is a differentiation fraction, at which particles decay per minute is proportional to the number of particles remaining n. Proportional. Okay, remember? So what we're going to do in here is the particles n. Okay, so dn by dt, because we are measuring the rate of the particles n over time. Okay, equals to proportional k to the number of particles remaining, kn. But it's a decay, so it's a negative. Okay, so negative because decay means decreasing rate of change. Okay, so that's the answer. So that's how we construct one quite easily in here. So dn, the rate means what we're measuring. What is the rate measuring? The rate is measuring for number of particles per minute. So dn, the number of particles, over dt equals k proportional k times. If it's inversely proportional with k over. Direct proportional means k times the number of particle, k times n. But it's a negative because it's decay. Okay, right, next one. Let me make it a bit bigger. The head of a snowman, okay, unfortunately, opposite to what I'm going to say, the snowman is actually going to decrease. I'm going to make it smaller. The head of a snowman is getting smaller, okay, of radius r loses volume by evaporation, and a rate, okay, remember the word rate. Rate means d something by d something. Okay, so d something by d something. I put a question mark there. Proportional to its surface area. Now, I want you to look at this. Hang on, loses volume. Loses means negative. Minus VE means negative. Or if you don't write abbreviations, you can write negative. Volume by evaporation at rate proportional. Now, proportional to its surface area. So K times surface area means k times a. Proportional to a surface area means k times a. Now, I want you to think about what is this rate measuring? Okay, what is this rate measuring? We're actually measuring the rate of the volume over time. Right? Are we? Hang on, this the volume over time. So we can rewrite this as dv by dt. Okay, so from this line already, we can construct saying dv by dt equals negative ka. So if you wonder where this come from, this came from here. So this the first line, how can I use a different color? Okay, I know how to. Like English, we can do something like English. We can put a 4 in here. This way it come from. Okay, so this way it come from. Next, assuming the head is spherical, that the volume of sphere is 4/3 pi r cubed, and that the surface area is 4 pi r squared, write down a differential equation for the rate of change. Okay, another differentiation fraction of radius of a snowman's head. So I want you to think about, what are we measuring in here? What is this rate measuring? What rate of change are we measuring in here? We're measuring the radius over time. So what we need to do something like what we learned about last lesson from last lesson. We need to set an equation. Asked by question equals given by question times the fraction made up by you. Okay. So this time the question, actually, can I copy this from previous? I can I? Yep, it works. Even though we don't need it. Okay, so we need to set an equation. Okay, so asked by the question. So we need to do asked by the question. So the question needs dr by dt. So we can set up dr by dt equal, given by question. The question sort of gave us dv by dt, right? Times the fraction made by you. So if you remember the shortcut from last lesson, it's going to be this numerator, and this is going to be a denominator. Okay, so dv by dt is negative ka, so dr by dt. Now the construction part is sort of done. What we need to do is just simplify. So I'm just going to go through the front part again before I continue from here. First of all, I read the question. I see a word rate. Rate means one rate means one differentiation fraction. So I realize this rate is measuring the volume over time. So proportional means k times, and then to its surface area, so k times a. But losers means negative. We're sort of like a English detective. We are investigating every single word in this paragraph in here. Every single, sometimes the word, you have to dissect. You have to apply the math into the English in here. So losers means negative because the rate of change is negative. Proportional means k times a. Okay, so and then we want to work out another rate, means this time is dr over dt. Then we apply what we learned last lesson, same equation, asked by questions. We want to work up dr by dt. We're given dv by dt, sort of, we're given, even though we made it up ourselves from the paragraph, but it's sort of given, times a fraction made up by you. Right? Next, dr by dv, we need to think of a formula or an equation that links r and v together. It doesn't matter which one is the subject in the formula, as long as there's a formula that links v and r together, then we can use that. Well, clearly we know v equals 4/3 pi r cubed. We need to find dr by dv, but we can work out dv by dr and then flip it over. So differentiate that one, times it by 3 becomes cancel with the third, so 4 pi r squared. So therefore dv by dr, flip it, is 1 over 4 pi r squared. So let's sub it in. So times 1 over 4 pi r squared. But we'll also know a is 4 pi r squared given by the question. Okay, so what we do is here, I'm going to rewrite that as negative k times 4 pi r squared. In case you need this. Okay, so we're told by the question, you can link it with the question 4 pi r squared in here. Okay. Right, next, so times it by 1 over 4 pi r squared, and then we can see 4 pi r squared cancel each other. So dr by dt equals negative k. What it means is the radius, the rate of change of radius over time, is simply a constant. Okay, that means it's decreasing by a certain number over, is it minute? What does t measure? T is, did it say about t? It didn't say about t. It could be per second, it could be per minute, depends what the measuring is. Okay, and that's the answer, right? Sounds complicated, But hopefully you sort of get it what we're trying to do in here. But if you don't, okay, but have a go at this question one. Let's see if you're able to try it. I would suggest you use a pen to try it first. 30 seconds. This is going to be something similar to the first example in here. Okay, so pause the video, have a go at the question. Now, this is going to be the structure of it. So you see a press question, pause, have a go. Okay, when you need help, then press play. Okay. Right. Press question one. I'll go through it. So the population, okay, let's use P, is growing at a rate of proportional. So rate, okay, proportional to the size of population. So this is going to be dP by dt equals Kp. Because we're measuring population over time. Proportional means K times. We're growing. Growing means positive. Okay, so Kp, population, Kp. Okay, that's it. Next one. Pause and have a go. When you're ready, press play. Right. Now, this question is slightly a bit more complicated, so I'll go through it. So liquid is pouring into a container at a constant rate. Now, again, the rate in here. Now, with this time, they give it to you. You can judge it by the unit. That's dV by dt, because centimeters cubed means volume, per second means per time. So dV by dt equals 30. Positive, because pouring into positive. At time t seconds, the liquid is leaking from a container and rate, another rate, judging by unit, is this time dV by dt again, right? Where V is the volume of the V is the volume of the liquid in the container at the time. Show that. Now, so you'll be thinking, how do we work it out? Well, there's one more thing in here. That's leaking. Leaking means negative. So dV by dt equals negative 2/15V. Right, so what we're trying to do in here, okay, how do we work it out? Well, think of this, okay, here's a cup, okay? Now, imagine you're pouring, okay, just imagine you're pouring, let's say 25 centimeter cube per second, okay, of liquid, okay? I love Ribena, let's put Ribena in there, or coffee. And then, now, but then some reason, okay, someone, okay, pierce a hole into my cup, okay, some silly ones. And then now my cup is leaking, okay, leaking by 5 centimeter cube per second. Now, can you tell me what is the net increase or net change, net rate of change in this cup? It'll be 20, wouldn't it? Because we're adding 25 and then subtract 5 every time. So that will be the overall rate of change. That's the same thing in here. We're pouring 30, but we're leaking 215V per second. So the overall change is going to be dV by dt equals 30 subtract 215V. But you can see they want dV by dt on the left-hand side and then with a minus 15. So now you can see we're sort of there, but they're just negative 15. So what can we do? Well, look at this. They don't have a fraction. They don't have a 15 in the fraction. So we can multiply everything by minus 15. So if we multiply everything by minus 15, right, then magical things happen. So times by minus 15, that becomes minus 15 dV by dt. Minus 15 times 30 is negative 450. Minus 15 times negative 215 is positive 2V. If I rearrange the 2V and minus 450, you can see that's the answer. Okay. Right, next one. Pause the video. Have a go at the question. 1 minute. Okay, when you're ready for the answer, you can press play. Right, so an electrically charged body loses a charge. Loses means negative 2 coulombs. Don't know how to say it. Let me Google it. Okay, I'm back from the from checking with the master Google. Yes, coulombs. And a rate. Okay, and a rate d something by d something. Okay, so d something this time we are measuring is the dq over dt. Why? Because we're measuring the charge per time, okay, per second, proportional to the charge q, so k times q. Work out, yeah, so we can simply do dq by dt equals negative kq. That's the answer, right? That's the answer. Next one, have a go, okay? Pause the video. When you're ready for the answer, you can press play. Right, the ice on a pond has a thickness x millimeters after time t hours after the start of freezing. The rate of increase, so rate of increase means positive, of x is inversely the rate, by the way, rate. This time we're measuring dx over dt. Okay. Inversely proportional, so k over something. Okay. The square of x, so dx by dt equals k over x squared, square of x, x squared. And that's it, done. Okay, so you've learned again, inversely proportional. This is about GCSE, coming from GCSE again. Increase means positive. Right, next one. Pause the video, have a go at a question. When you're ready for the answer, you can press play. Now this one, maybe I'll give you the answer one by one, so then you can have a go at the next one. Can try itself. So pi dc by dt, where c is the circumference of the circle, is in oh, by the way, sorry, hang on. The rate of circle is increasing at a constant rate of 0.4 centimeter per second. So the rate we're measuring the radius of, so dr by dt equals 0.4. Find dc by dt. So we need to use the same structure again. Given by the asked by the question equals given by the question times, you need to make it up. Right. So we know dc by dt equals dr by dt will give us 0.4 times dc by dr. Now we know dc by dr, c equals 2 pi r. So dc by dr, now this fact you have to know this, circumference equals 2 pi r. Differential that is 2 pi. So we can put it in. So dc by dt equals 0.4 times 2 pi r, not 2 pi r, 2 pi. And then, yeah, so dc by dt equals 0.8 pi. The unit of circumference, centimeter, time we're measuring per second, so centimeter per second. Okay, that's part A done. Okay, if you struggle with it, here's the answer. Have a go at part B. Okay, if you've done it, carry on listening. Part B, find the rate at which the area is increasing. So this time we want to find dA by dt. dA by dt, let me put it here. So it's dA by dt. So we have to make up something similar this time. The question wants us to find dA by dt. We are given dr by dt, so we just have to times by dA by dr. Right, so the same thing, dA by dt equals dr by dt is 0.4. Area and radius. The formula that combines area and radius, a equals pi r squared. So we can do dA by dr equals 2 pi r. Drop it in. Times 2 pi r. So dA by dt equals 0.8 pi r. We're told radius is 10. When r equals 10, so dA by dt equals 0.8 pi times 10, which is, you can write 8 pi, or, yeah, just 8 pi. I just wrote it as 8 pi. Centimeter square per second, because it's area, centimeter square per second. 8 per time. Right? That's it. Right? If you haven't done C, have a go at C, try it. If you haven't, then you can carry on listening. But I'll suggest you try it out first. Because there's actually no homework for this question, for this lesson. It's all about just trying these questions out. Part C. Find the radius of a circle when its area is increasing at a rate of 20 centimeters squared per second. Find the radius of the circle when the area is increasing. So this one, we are told dA by dt equals 20. Now this, I want to find the radius, so to work backwards. So part C. When dA by dt equals 20. Now when you find radius from dA by dt, so we're going to search our working out. How do we work out dA by dt? Or what's connecting between dA by dt and radius? Well, the only connection is from here. So we can use it. So when dA by dt equals 20, so we can write 20 equals 0.8 pi r. So r equals 20 over 0.8 pi. Put in the calculator, you get roughly 7.96 centimeter. I put F3 as that. That's done. Okay. Right, next one. Okay, this one. Again, I would suggest you try out first. Okay, doesn't matter where you stop, but at least you have to try out first, because starting from here, the question will start a little bit more complicated. So you need to try out. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, so let's go through. Fluid flows out of a cylindrical. Flows out means negative, right? With constant cross section. At time t minutes where t is greater than 0, the volume of fluid remaining in the tank is V. The rate, right? So rate d something, which the fluid flows in meter cube. So I know meter cube means volume per minute over time, right? Is proportional. Now this rate is flows in, means positive. Proportional. So proportional means K times square root of V. Right. Show that the depth h meters of the fluid in the tank satisfy this differential equation dH by dt equals negative K root h. So this is what the question wants. So we use the same structure. Again, where was it? Where was the... Okay, oh, here we go. So the question, this time the question is asking for dH by dt equal. Oh, hang on, my bad. I was wondering why is it positive and negative. My bad. In here, okay, English problem. The rate at which the fluid flows, okay, flows out, okay, flows out in the unit in meter per second. So there's still a negative. Sorry, my bad. It's still a negative because flowing out. So it's negative. Okay, English flows. They should put a comma in there. No punctuation. The importance of the punctuation. Yeah, if I have to be really, there should be a comma, no? Comma. Right. So given by the question, we're given dV by dt times made up by u dH by dV. So dV by dt, we're told is negative K root V times dH by dV. You need a formula that links V and H together. So the formula is, we know this is cylinder. So volume equals pi r square H. Right? So we need dV by dH, dV by dH. Now radius remains unchanged. H is a variable differentiating here, so the rest of them remains constant. It's like differentiating 5H is 5, so in here is pi r squared. Right? And then we're going to find dV by dH by dV. So dH by dV is 1 over pi r squared. So I can sub it in. So let me rewrite the whole thing again. So dH by dt equals negative K root V times 1 over pi r squared. Right, what's next? Well, we are getting there. You see, it's not the same as the question, because the question is a much more simplified term where they have root h, where we have root v. So these two variables are not the same. So that means we have to do something to this v in here. Well, the connection between v and h is that v equals pi r square h. So we can sub it in. So d h over dt equals negative k times pi r squared h times 1 over pi r squared. So what I've done in here is I've replaced v equals pi r squared h. So what's next? The question wants root h, right? So then what I'm going to do is I'm going to just keep the square root with the h. I'm going to separate these two. So negative k times root pi r squared times root h over pi r squared. Right, then next, k is a constant in here. So this k is not the same as rk. because they, well, even though they look a similar variable, but k, imagine k is just a constant. So k is a constant means it could be a very complicated constant. Constant means 0.8 is a constant, 5 is a constant, 3 over square root of 3, I don't know, 0.46 is also a constant, because as a constant means just a numerical value. It doesn't mean, it could be integer, it could be a decimal, it could be a fraction, but it's a numerical value. So in here, we know our case also a constant, a number. So what we can do is we can let this to be another constant, because if you have to put this in a calculator, we know actually, yeah, we know radius is a constant in here. They all simplify into constant. Constant means a numerical value. So just imagine, okay, so imagine this is essentially minus 4 times 5 root 6, not minus 4, we ignore it, take out the minus 4 times 3 times root 6. Now, without putting a calculator, I know this will simplify into a number, right? If I put a calculator, I know it was, if I imagine I didn't, but I know by putting a calculator, it can help me simplify into a constant. So I can let this to be, I can let this k to be this whole weird thing. Yeah, so that's what I'm trying to do here. I'm going to I'm not going to use k, I'm going to use k1 because it's different. K1 equals k root pi r squared over pi r squared. And yeah, so if I let this happening, then I can say dh by dt equals negative k1 root h, which is what the question needs. The question just wants a constant in the front times root h, and that's what we've done. A slightly new concept in here, but the reason I want to write in this format is this looks a lot neater than this one here, because k1 is just a number. We don't care how complicated the number is. It's just a number in the front. Okay, so the same thing here. 4 times 5 root 6 over 3 root 6 times root h. We can simplify this into k root h. Okay, so yeah, right. So new concept in here. Next one, the very last question. Now, before I let you do the question, I would like to draw a diagram for you. So just let you picture it. You can pause the video, read the question first, see if you're able to draw one yourself. So this is diagram. Okay, so this is what we talk about, the inverted conical funnel. So this is what it looks like. Okay. So I'll let you read the question again. Try to write down as many things as you can by digesting the paragraph, writing as many, mathematical things that you can do, leave as many notes as you can, like what we did with positive, something like this, making notes of the paragraph. Again, this is a difficult question. So pause the video, okay, have a go at the question. When you're sort of ready for the answer, you can press play. Right, so let's read the question together. An inverted conical funnel is full of salt. It's a bit salty. The salt is allowed to leave a small hole in the vertex. That means there's a little hole in there. That means it's leaving. Okay, it leaves at a constant rate of 6 meters cubed per second. So we have to know this means dv by dt, v because centimeters cubed, t because per second, equals leaves negative 6. Okay, next. Given that the angle of the cone between the slanting edge and the vertical is 30 degrees, I told you that. Show that the volume of the salt is 19 pi h cubed. Now that's the first question. I'm going to put 1 in there. Okay? Where height is the height of salt at time t seconds. Now, and then another show that. So that's another show that. Okay, show that, another show that. The rate of change. So show that the rate of change of the height of salt. So let's read this. The rate of change of the height of salt is inversely proportional to h. Can you make this out of it? The rate of change of the height, the dh over dt, is inversely proportional to h squared. We know the rate of change because the salt is leaving from the vertex, like a funnel is leaving. So we know it's not being negative. So one by one. Oh, there's third thing in here. Write down a differential equation relating h and t. So we've got 3 questions in one. 1, 2, 3, 4, 5, 6. 6 lines, 3 questions. Not very proportional, is it? Right. So let's do number 1. Show that the volume of the height of the volume is 1/9 pi h cubed. So volume. So we'll try to work out number 1 first. Okay, so volume. So we know the volume. So volume equals pi r squared. Oh, actually, the volume of cone is 1/3 pi r squared h. That's the volume for cone. Well, how do we remember the volume of cone? The formula. Well, cone is a pyramid of a cylinder. Any pyramid of a cylinder of a prism. Any pyramid of a prism is 1/3 of the volume of the prism. So, for example, if you have a cylinder that's pi r squared h, the pyramid version will be 1/3 of it. Let's say you've got a cuboid, right? The pyramid version will be like a rectangular base pyramid. I think I've done a good job of sketching it here, so that this, we know the volume of this is length times width times height. Yeah, or yeah. So in this one, it's a 1/3 times length times width times height. The same thing in here. But anyway, so volume of a cone is 1/3 pi r squared h. But if you look at the question, there's no radius in there. So we need to replace the radius. So how do we replace the radius? We can use a 30 degree, right? So right, so tan 30 degree equals radius over h. You can think of like this. That's radius, that's h. So we can use trigonometry. So that we can make radius subject tan 30 degree, put in a calculator, is √3/3. So it's √3/3 h equals radius, and we will write that on the left hand side. So therefore, v equals 1/3 pi r squared times height. The volume equals 1/3 pi. Let's square the √3/3. If you're unsure what to do, just plug in the calculator, √3/3, the whole thing squared, and I get 1/3 times 1/3 h squared times h. So that will give me, simplify the algebra, and the number 1/3 times 1/3 is 1/9 pi h squared times h cubed, and that's what the question needs. Okay, question 1 done. Next, question 2. Show that the rate of change of the height is inversely proportional to this. Now I want to show this, so this comes back to the same structure like we did before. Given asked by question equals given by question times made up by you. So this time, let me copy this. Can I copy this again? A bit messy. A bit messy. Ronaldo fans won't be happy with me. I mentioned messy. Right. Next. So asked by question. The question is asking for dh by dt equals given by the question. The question gave us dv by dt. So what we need to do is we need to make up one fraction. This is the numerator. This is the denominator. So dh by dt equals dv by dt, which is -6, times dh by dv. When to relate v with h, we already got one from number 1. So from 1, so v equals 1/9 pi h cubed. So dv by dh, differentiate that. Bring the 3 down, is 1/3 pi h squared. Power goes down by 1. So we can sub it in. So dh by dt equals -6 times 1/3 pi h squared. 1/3 times -6 is -2, so -2 pi h squared. If I made a mistake somewhere. Oh yes, I made a mistake. Did anyone realize what mistake have I made? I forgot to flip it over because it's dh by dv. Silly mistake, silly mistake, silly mistake. So, you know, quite normal. So dh by dv is, flip it over. Flip the 1/3 is 3. Flip the pi h squared, that will be denominator. we times it by 3 over pi h squared. That gives me minus 18 over pi h squared. Now we can use the same trick because like question 16, we have to let that to be a k, because now look, but you have to be careful what you let k to be. We want a negative, so we're not gonna include the k in the negative because it's a negative over h squared. That means the rest of them will be a k. 18 over pi will be k. So we can let k equals 18 over pi, so dh by dt equals negative k over h squared. Okay. Right, number 3. Write down a differential equation relating with h and t. Have we already done that? Show the rate of change. Find the differential equation relating h. Actually, we've done equation. We've done number 3 already as well, because there's a differential equation. Because this equation has a dh over dt, that's called differential equation. Anything regarding there is a differentiation fraction inside the equation is called differential equation. This is called differential equation relating h and t. This dh by dt, so that's it as well. That's it. That's done. So this number 2 and number 3. Let me use different color. And now I know it sounds complicated in this lesson about constructing, but I have told you in the beginning of the lesson this is going to be a more difficult part of the question. But you will see later on in chapter 11 when we come back to this, some of the questions are the easier types of what you usually find is sort of these questions maybe perhaps, or something about these ones, and then you're given something you want to solve it. So the construction part, as complicated as it could be like these ones, most likely it's not going to be as complicated as this one, or they give you a bit more hint how to work it out. And then the next part of the question of this chapter about differential equation is we need to solve this using integration, but that's a later thing to do. So yeah, and that's the end of differentiation. Now I know today's lesson we talk about quite a lot of things in here about differentiation, differential equation. You sort of take the eyes off the chain rule, product rule, and quotient rule. But these rules are going to come in handy later on in integration again. So the main part of differentiation chapter is about the rules we talk about. Okay, and then we're going to use this later on in chapter 11 again. And that's the end of differentiation. And that's the end of the lesson as well. Thank you.